He's already been dead and it's messed with his head. It's John's post-life crisis.
Welcome to John's Post-Life Crisis. I am your host, John Johnston, founder and manager of CornNation.com, your Nebraska Cornhusker site of happiness, because happiness is a choice you can make no matter what's going on. Today we're talking with Dr. Stuart Weston. Dr. Weston is a research fellow at the University of Maryland School of Medicine in Baltimore, where he has been studying coronaviruses before it was cool. So how long have you been studying coronaviruses?
So I joined the lab that I'm in back in 2016, right at the end of November 2016. So we've been studying coronaviruses. Well, I've been studying coronaviruses for the last near 4 years now. But the lab I'm in, so my boss, he started his lab in about 2010 on the back of the original SARS outbreak. So he's been studying coronaviruses for a long time. And as you say, we were doing it before everyone jumped in and everyone realized how interesting these viruses are and how dangerous and destructive they can be.
So you mentioned SARS.
Sure.
COVID-19 is a coronavirus, but it's one of many coronaviruses. We need to start with the basics here because I still have people in my life that say it's just the flu. And my understanding is it's also a novel virus, and that means we've never seen it before. How can all of this exist at once?
Sure. So just as a little point, so COVID-19 is actually the disease that's caused by the virus called SARS coronavirus 2. So similar to how HIV is the virus that causes AIDS, COVID-19 is the disease that's caused by the virus SARS coronavirus 2 or SARS-CoV-2. So the 2 suggests there was an original, which was SARS coronavirus 1. So that was a virus that spread from about 2002 into 2003 for about 8 months or so. And it spread around the world, again, from China, similarly to this virus we've got now. But it only caused about 8,000 cases and killed about 800 people. So nowhere near to the level of what we've got now. But a similar type of virus, in that case, the disease was just called SARS, which stands for Severe Acute Respiratory Syndrome. So there, SARS was caused by SARS coronavirus. So here it got a bit more complicated with the naming for whatever reason, but just to differentiate things. So we have COVID, which is coronavirus disease, 19, because it came in 2019 was when this virus started spreading. But as you say, there are other coronaviruses out there. So in 2012, we had an outbreak of Middle East Respiratory Syndrome coronavirus. So this is MERS coronavirus. So that's, as the name implies, it originated in the Middle East. But that virus doesn't spread very well in humans. So since 2012, there's only been about 2,500 cases of that virus. So it still spreads occasionally. There's still sporadic cases every now and then. But it's a different virus, causes a different disease, and it's actually a lot more deadly. So that virus kills about 40% of the people it's infected. But then, as well as these really severe ones that I've mentioned here, there's 4 other common coronaviruses that cause common colds. So some of these were known before the severe ones, and some have been found since the SARS outbreak, and people started to look at coronaviruses more. But they just spread in the winter. So whenever you get that blocked up nose, bit of sore throat or something, that often is a coronavirus. Some estimates suggest about 30% of common colds are caused by these common cold coronaviruses. So there's this big spectrum where there's these sort of 3 that cause really, really severe disease and are lethal or cause, this broad spectrum of symptoms of COVID-19. But you also have these less dangerous ones which just cause common colds.
Oh my God, this is hard.
Information overload, possibly.
Well,
sorry.
I keep trying to think of this, and what I think of is car manufacturers, right? Like Ford is a coronavirus, and Ford makes the Fusion, the Mustang, the F-150 pickup. There's all these different types of cars, and they do different things. Is that a really dumb analogy, or does that work?
No, that's actually a really nice way to look at it. I typically try and a way I explain it is it's kind of like how there's humans, there's frogs, there's chimpanzees. So there's animals that we're all animals, some are closer related than others, but we're all different. I think the car analogy is also great because Ford is the overarching thing. So coronavirus is, and they've got all their different models. And then you've got Toyotas and things like that. So flu would be a Toyota, for example.
So in real, hopefully simple terms, what makes a virus more, you mentioned that some are more dangerous. What makes a virus more virulent? And my understanding of that word means it's more contagious. Am I correct?
Yes, I mean, yeah, and it's a great question because that's one of the core questions within virology. So people studying viruses, it's one of the core questions is why some viruses are so dangerous and lethal and why some others aren't. So, for example, Ebola, as you may be aware, kills anywhere between 50 and 95% of the people it infects. Why that is a really big question of research. In terms of the coronaviruses, there's a thought that it's down to how long the virus has been spreading within the human population. So obviously the SARS-2 virus has emerged at the end of 2019. So we've only had it circulating in humans for whatever that is now, 8 months, 9 months or so. And because our immune systems have never seen it, there's no one who's immune, no one who's had it, it can spread rampantly and make a lot of people sick, as we're seeing. Whereas the other coronaviruses, those common cold ones, some of them have been around for potentially hundreds of years. So they might have decimated populations back then, similarly to what we're seeing now. But then people develop immunity. It's harder for it to spread as rampantly, and maybe a feature of viruses is sometimes that they become less virulent the more they spread. So a virus is it's a small, it's actually, to use your car analogy, it's just a small package that delivers something. So the car is just a way to deliver you. It just delivers its genetic material and it makes more of itself. That's all a virus does. It just copies itself. But if it kills the person it infects straight away, kills 100%, it's got no one to then make more of itself. So it's actually advantageous sometimes for viruses to not be so lethal. So this is kind of something you see that the longer a virus is in the population, the less dangerous it becomes.
I suddenly World War Z is popping in my head, and we shouldn't go there.
No, probably not.
You're working on treatments for COVID-19, and treatments are different than a vaccine. Explain treatments.
Sure. So treatments are generally things that would be given to someone who already has been infected, because treatments can come with side effects. So certain drugs can have side effects. So you don't want to necessarily risk giving it to everyone, the cost associated and the distribution, all those kind of things. So they're more for people who've already been infected as a way to help deal with the symptoms and to help stop the virus spreading within the person. So the more the virus grows within a person, the more damage it can cause, the more severe the disease. So if you can limit how much it grows or limit the damage it causes, then you can stop severe disease. And so that's sort of where treatments are aimed. There are treatments that can be designed to be given prophylactically, so before you're infected. And those are sort of going to be more directed at people who are at high risk. So for example, with HIV, there is prophylactic treatment, which is given to people who are at higher risk of contracting HIV. And with something like COVID and SARS-2, it might be the healthcare workers who'd receive something like that. With vaccine, sorry, go on, yeah.
So since you have existing coronaviruses, I mean, is that like a blueprint to start with?
Yes.
Figure out where the variables are?
Yes, and obviously I know you do this as a podcast, so people won't see that I was smiling as you say that, but I smile because they should have acted and could have acted, but as that blueprint, but there was a lack of money in the research for these things. So when the SARS-1 outbreak hit in 2002-03, there was a big spike in funding for treatments, for vaccines, and I'll circle back to vaccines in a second. Similar thing happened with MERS. There was a big spike in the funding. After those outbreaks stopped spreading, that funding went away. And so it was a lot harder to research these viruses, and the coronavirus field was pretty small until the start of this year. So that's why I said, well, I joke that we were doing it because before it was cool. So it was hard for us to develop treatments and vaccines because there wasn't the money going into it, because money was going into things that were actively there, not to prepare us for things that could appear, if you see my meaning there. And so, and just like I say, to come back to vaccines, they are truly prophylactic. So they are given to prevent an infection. And again, if there'd been the money going into it, we could have had vaccines. There's a very good scientist, a vaccine expert, Peter Hotez, who's been on a lot of the news channels. People have probably seen him. He always wears a bow tie. He's done everything from CNN to Fox. And his lab made a great SARS-1 vaccine back in 2003. They got it towards the stage of clinical trials, and then they lost the funding and couldn't start doing any trials. Had they been able to, they'd have known that that was safe, and they could have just changed that vaccine platform to SARS-2, and we could have been a lot further along. But we don't have unlimited.
We're humans. We're distracted by shiny things that come along, and we get tired. We look at that thing over there, and we go, "I'm tired of that thing I've seen for a while. There's the shiny thing now." You know,
and also we don't have unlimited money, right? That's the other part of it. So of course we're going to get distracted by the new thing. So take whatever it was, 2014, when there was the Ebola outbreak. Of course, a huge amount of focus gets put on that because we've got to stop this. Right now, there's a huge amount of focus on SARS-2. In a few years, it might be SARS-3, or it might be a new strain of flu, because it's the active thing we have to deal with.
So how many different types of, I don't know if they're medicines, drugs, Thomas Edison supposedly tried 84 million different combinations before he got the light bulb. How many variables are there that you guys have to work on to discover if there's a treatment for this specific virus?
Well, so endless numbers, really. There's been quite a focus, and something we've been doing in the lab was to focus on drugs that are already approved for use in humans. So until it's used in a human, it's typically called a chemical, and then it becomes a drug when it's used as a treatment. So the FDA have approved hundreds upon hundreds of drugs for use for various different things, be it cancer or diabetes or whatever. And what you find in the lab is a lot of those drugs can have effects that inhibit virus growth in cells in the lab. So this is an idea of, it's called drug repurposing. So the drug is used for something else, and you could potentially repurpose it to treat a viral disease. I'm sure we'll get to it, but this is sort of where chloroquine comes in. So chloroquine was used, or is used, as an anti-malarial and used for lupus and some other inflammatory diseases. But also in cells in the lab, it can inhibit growth of the virus. So the reason for doing that is those drugs we already know are safe for use in humans. So you can get them into humans suffering COVID-19 quicker because they're safe in healthy humans for treatments. The other approach is to test a load of different chemicals that have shown promise as antivirals, which is where remdesivir came in. So the remdesivir was being developed by Gilead. I think it was initially for treatment of HIV, but then it was used for Ebola. And it was a new chemical that was being used, and it's also effective against coronaviruses. So now it's being used in COVID patients. So you can see the breadth of options. Yeah. And then there's all these chemical libraries out there, which is something I've worked with I was working with before SARS-2 arrived. I was doing it for some other research, looking at these really broad libraries of chemicals to see if we could find things that are antiviral that you could then make into treatment options. And that's not even, sorry, go on.
You mentioned chloroquine, and then there's this extension to that, hydroxychloroquine. Whenever you say that word, it connotates some guy that has a really high profile. Everybody poops themselves. And then we come up with demon sperm, which if you've been on Twitter, demon sperm makes sense to me. But
sure. In the same way drinking bleach does.
Well, this has become so politicized that it's as if you'd say, it's as if you're in the position where you said there might be some value in this, people would freak out and, I don't know, drive to your house or something.
Well, yeah. So I'm
It's
glad
not
you
really
thought
that's not really a virus research question, I guess. Maybe that's
so.
improper, but you can answer it if you want.
Well, yeah, I mean, it's something I've thought about because we've actually got a paper that we put up onto a preprint cervical bioarchive a few months ago, and we've now just had it accepted for publication in a peer-reviewed journal, where we show the thing I was just saying, that chloroquine, hydroxychloroquine inhibit growth of the virus in cells in the lab, which various other labs around the world have shown. And we showed that chloroquine treatment of mice didn't stop the virus growing, but it stopped them developing signs of disease. So obviously we can't work with humans, so we use mice as a surrogate to look at the course of disease. But for that, we had to give it to the mice before we infected them and all the time while we were infecting them. So it's protective if you just really highly dose. So there is some idea that maybe there's some use to it. The problem is this disease it's very weird. There's a lot of things that can inhibit the virus in cells in the lab, but then when you put them into humans, they don't work. And that's kind of the problem with finding treatments for viral diseases, and it's why we don't have hundreds of treatments already, because hundreds of drugs work in the lab, but if you put them into mice or you put them into humans, they don't work. It matters when you give it to that person in the course of disease. Obviously, as I said, in our mouse study, we had to give the drug before we infected. People who are going to try and get treatment with hydroxychloroquine are already in hospital. They're already in that severe stage of the disease. And so far, the best evidence from the good studies is suggesting that chloroquine and hydroxychloroquine are not effective for treatment of COVID-19. Now, obviously, there is a lot of back and forth. There's some people who say it is, some people who say it isn't. And what I've started to think about with regards to that is that's kind of how science always has worked. Science has always had this back and forth, but now it's in the public eye so much more, and it's at warp speed. Everything's coming out, new stuff every day, because everyone wants that treatment. Everyone wants the miracle cure. So you're seeing science that normally takes 10 years until we hit a consensus of it does or it doesn't work. And we're seeing that microcosm of it right now in full view of everyone. So of course people can get carried away, can get excited and jump on it. Oh, it works, because they see the one study that says it works, but don't see the 5 that says it doesn't. And so it just takes a bit of time to hit the consensus. And the human body, the human beings, we are these complex, strange organisms. And so it's very hard to actually make drugs that are effective. And we're seeing that in plain view now.
I think it was Stephen Hatch wrote a book called Snowball in a Blizzard. It's about trying to breast cancer and looking at radiology reports and literally trying to determine if you have breast cancer versus the snow that is a radiology report. And I think in that book, he said something about most of the times in the media, the focus is on human interests, so that the media really doesn't understand how to handle health and science news, because the focus is not a human interest story. So they warp it. You know, they'll go, oh, this hydroxychloroquine, and then they'll tie it to a human who was somewhere, because they don't know how to write about science. I guess there's not really a question there, maybe, but
no, but I think it's a nice comment. I think, yeah, you've kind of encapsulated what I was trying to get at in a different angle of it, that, yeah, the media try and make it about the people. And then if people don't think in the same way as scientists, which I don't mean as a criticism, but if you don't think about the fact that, yeah, there's one study showing it's good, there might be some others, let's compare and contrast. Is this a good study? Is it not? It's harder to assess things. And obviously everyone wants that positive mindset of, yes, this works, this is going to be the miracle cure, when caution is more the mindset within science of it probably isn't. Let's try and disprove our hypothesis, right? That's the way science is done. It's let's disprove this hypothesis. Oh, I can't, therefore maybe it does work. So sorry, go on.
Basically what you're saying is there's nuance and discussion, something that doesn't exist a lot because we pay so much attention to Twitter, where there is no nuance or discussion. There's only screaming.
Yeah, there's only so much nuance you can get into 140 characters, or 280, whatever we're at now.
Yeah, that helps so much. Okay, immunity. Are we done with the treatment part? I don't mean to cut you off, because obviously you probably could go on about that for 8 or 10 hours.
Yeah, I mean, just I guess to sort of summarize it is there's a lot of things that are being looked at. There's new drugs, there's old drugs being repurposed, and we just need them all to be done in proper clinical trials and not these rushed trials that have problems where there's no placebo controlled compare against or whatever it is. And eventually we may get a treatment, but about immunity, vaccines are probably our better approach, or where we should be really looking for that. I don't want to say miracle cure, but the miracle cure, the thing that's going to really make a difference.
Okay, so we have treatments. We potentially have a vaccine at some point. There's this word called efficacy that's really difficult, because people look at a vaccine, they go, well, that should cure everything, and really it might be 50%. And then you have these people that won't wear masks because it's a political statement, and then they probably won't take the vaccine because Bill Gates is involved in it. This is horrifying. All of this stuff is just, and a lot of it is not science. And once again, I'm not sure I have a question there, but on the immunity thing, do they know if it lasts a long time? Is that something you can comment on? Is that outside your field?
Well, so with immunity, it's an evolving question for this virus, because obviously, as we're saying, this virus has only been known about since the very end of December, start of January kind of time, and therefore we haven't had the time to really see if people are truly immune, because it's only been here for a certain number of months. What we can do though is we can extrapolate, or we can work on what we know about the other coronaviruses. So with the common cold coronaviruses, those 4 that spread and just cause those mild colds every winter, what we generally see there is that people are immune for about 1 to 3 years or so, and then you can be reinfected. So if this virus is anything similar, which, to come back to your analogy, it's still made by Ford, it's still within that family, so there's likelihood that there is similarities, you may suspect that people could be immune for up to a year or so, naturally. So people probably are protected from reinfection. There's complexities within it, again, because there's this such laser focus on what's going on now. There's these studies saying, oh, the people lose their antibodies within this length of time, therefore they're not immune. But then there's also now studies saying, oh, but the other part of that immune system's really still good in those people. So they're just looking at antibodies, but there's also T cells as part of the immunity. It's these 2 arms, antibodies and T cells. Antibodies might go down, but T cells may be up. So people may still be immune. And again, because we've got so much focus on each little step of the way right now, there's all this confusion that's arising that will slowly sort of clear itself out, and we'll start to develop a picture. But based on coronaviruses, you are probably immune for about a year or so at least. Okay.
I know this is speculation, but I want college football. I don't know if it's going to happen. You know what I mean? But basically what that means is people want life to return to, quote, normal, unquote, right?
Sure.
I personally don't think there's ever going to be a return to normal, just because that's a long discussion. Economic influences, psychological influences, educational influences of kids being out of school or in school for a year, things like that. Is there a path back to mostly normal that you can kind of give us? Or I know it's speculation, but we speculate a lot. Everything is.
Sure. Yeah, I mean, I think when we get vaccine, and a vaccine or multiple vaccines, which I do think is a case of when, not if, when we get vaccines, I think that's when we can start to get back to that new normal. I don't really like the expression, but mostly normal. I'll use your expression because I think I'll prefer that. That's when we might get back to a mostly normal, even though people may not take it. It may only be 50% effective or whatever. That's still when we can go back to what we used to have more so, is my speculation. Because even if only 50% get it, that's still a lot of people who are immune. There's also a lot of people who would have had it by that stage as well. I mean, it's bad that it's spreading, but more people are becoming immune. So if we vaccinate all the people who've never had it, then you cover more and more people, and the more people immune, the harder it is for it to spread. So if you've got, say, 10 people together and only one of them is not immune, only one person can get sick. So the more people that are covered, this is an idea called herd immunity. And so once we get the vaccine, that's how we can go back to what we may think of as sort of normal. But I think as well, in the meantime, because the vaccine is probably not going to be here until 2021 time, and obviously we'll have approvals in early 2021, I suspect. But then you've got to ramp up production, you've got to get it out to people. So it's just going to be an ongoing thing through all of next year before we're actually covered in the same way we are with the flu vaccine, for instance. But I think in the meantime, the thing that's going to be powerful is testing. So as we improve the testing, if we can get tests down from being, a day at best to 2 weeks at worst for getting your results, if we can get that down to 3 hours or 30 minutes or 15 minutes, which is what some of these new tests are promising, that's potentially how I think we can get more normalcy back. So as an example, so you're saying you want football back and probably want to be in the stadium and things like that. If you can test all of the players and get a result in 15 minutes, they're all clean, all the coaching staff are all clean, they can go on the field and play without any concerns, potentially, if the test is perfect. Similarly, then, if you could test all the fans and you could do some kind of bubbling, so maybe 70% capacity, but you've tested everyone, they get their 15-minute test as being negative, I think that's how you can start to go back to normal. Similarly with school classrooms, right? If everyone can get a test, stand outside for 15 minutes, wait, check their watch, yep, negative, you can come in. I think if we can get that technology really ramped up and around, that's when we might be able to go a bit more normal.
How far away do you think that is?
So there are companies that have now had approvals for those kind of tests. So BD, Becton Dickinson, for example, I've got a few friends who work for them here in Maryland, and they've had an approval for a 15-minute test. I think Abbott have a 15-minute test as well. I think that's the one that's in the White House. I could be wrong on that one, but they've got, I think, a 3-hour turnaround on their testing. And it's just a case of them being shown to be very effective. Because obviously what you don't want is to get a load of false negatives, because then you have a false sense of security and you end up spreading. So these need to go through a lot of testing, because if we can mass produce them and we can roll them out to a lot of places, that's important, right? So you don't want them to be wrong. So again, it just takes a bit of extra time to really make sure they work. But there's multiple now that have the approval. So I do think they'll be coming online speculatively. I base this just on a thought, around 2021 as well. So as the vaccine is getting ramped up to be given out, we'll hopefully have these tests in places and we'll be able to cope with things better.
This is maybe a dumb question, but when it comes to like the testing and efficacy, I pronounced that wrong, its ability to actually be proper without a false positive, as you said. I mean, how do you know that without people already being infected? Maybe wrong.
No, so I mean, all of that kind of testing is the stuff that's done in labs beforehand with known positive samples and known negative samples, and then it will start to test in humans and it will start to roll out there, but just in small cohorts. So similarly to how clinical trials are done, you start with a few hundred people, you make sure it's working, you compare it to other tests that have already been validated. So if you know that there's a test that's 95% accurate and yours is calling all of the same things as positive and negative, you can build up a sense of whether it's working. And then you just build it up and up and up until you're confident that it really is accurate.
Okay, so I have to mention masks, just because that would be the complete, if we didn't put that in the recipe, somebody would go, you didn't say anything about that. The masks, people are freaking out about this. I personally wear a mask when I'm supposed to, when I go out, just because if there's even a possibility that it helps, why would you not do this? It's so simple, and you can play dress up. That's what I think of. When this first started, I wore a red bandana and pretended I was a bank robber, for crying out loud. Now I wear a gaiter and I think of myself as a ninja. I comment on the mask situation.
Yeah, I find it weird that we live in a world where a piece of cloth has become a political statement, I guess, is my thought. And yeah, I agree. Even if they aren't working, they're not harming, and all of the evidence is suggesting they are working as well. So places that have got less spread are typically the places that are more compliant with masks. Places in Asia, so Korea and Japan, they really got in control of the outbreak a lot quicker than other countries have. Partly that's because they were better prepared. They learned lessons from SARS and MERS, for example, in South Korea. But there's also more of a culture of mask wearing in those countries as well. So they're a lot more inclined to wear masks. So evidence suggests they work. If you do all these kind of studies where you look at the droplets that come out of people's mouths and you shine lights on, so similar to how you can see dust when light streams through a window, you can do that with respiratory droplets, which is how the virus transmits. Those kind of studies show that masks block or reduce the droplets that come out. Obviously, that's just looking at the droplets, not the virus itself, but it's a proxy that they're working. And yeah, it's just a piece of cloth that you put over your mouth. And as you say, you can make it part of your fashion statement. You're wearing your red one. I just got given, I mean, it's not going to show on the podcast, but I just got a branded University of Maryland, Baltimore one sent to me. So, you can get all the designs, do the fun things. And as you say, if there's no obvious harm from wearing them, so I don't see why people find it such a problem. And also the other part that I've talked about with people before is you don't always have to wear them. So I sort of see people sat at home with their masks on or sat in the car by themselves. And I think that's why people start to think it's oppressive, because the messaging's not always spot on sometimes. So people think they're being told they always need a mask on, which isn't the case. It's when you're in a situation where you're at risk and you're putting other people at risk, when you can't be distanced from people, when you're in a confined space with other people, that's when you need a mask. But just sat at home, sat in your car by yourself, or with the people that you live with, things like that, you're with them all the time, you're always at risk. So it really is, it's about putting the mask on when you can't distance yourselves from other people that you don't regularly spend time with. When you're indoors, particularly outdoors, there seems to be less transmission, so it's less important to wear a mask. I see people running, for instance, with masks on. I wouldn't want to do that myself, for example, but I wouldn't feel uncomfortable not doing it because I'm outdoors. I'm not in any kind of prolonged period next to someone talking to them and things. So I think there's nuance, right? Coming back to what we were saying, there is nuance, and I do understand that people have this concern that they're being told they're being oppressed for always wearing a mask, but that's not the case, and the masks are working. They are protective and they do block spread.
You have a YouTube channel where you talk more in detail about this stuff. I tried looking at some of those. I find this stuff absolutely fascinating. My background's in IT, so I never have to deal with humans. I did try to understand your stuff. I almost suffered a brain aneurysm, which would have been recorded as a COVID-19 death, obviously. Tell us about your YouTube channel.
Yeah, thanks. So I started the channel a few months ago. I guess I'm up to 30-something videos now. I was sort of convinced into it by friends and family, because just before we were going into lockdown, so back in sort of that February, March kind of time, I found I was in a lot of conversations similar to the one we're having now, talking to people about what's going on, what I think will happen. And then we went into lockdown and I'd spend less time in bars talking to my friends about this sort of stuff. So I got convinced to do a YouTube channel to talk about it and to take a bit of time explaining various different aspects. So obviously here I've tried to compress a lot of things into small segments. But what I do on the channel is I spend a bit more time unpacking each of those things. So my most recent video, for example, was talking about wearing masks. I've done other videos talking about hydroxychloroquine, and so I do sort of a 5 to 10 minutes or so spiel of me just talking to the camera, explaining some of the stuff that's going on, and trying to give the scientists' eye view to help with some of the mixed messaging that we're seeing in the media and things. Again, what we're just talking about. So just trying to provide a voice of sanity, I guess, in these strange times, and provide some good information. That's my hope for the channel.
So would you go on record saying that Demon Sperm is responsible for Twitter?
Oh, I don't know if I can put that one on Jack Dorsey. No, I will not go on record saying that. I will go on record saying Demon Sperm is not responsible for COVID-19, but and I will also say don't drink bleach and don't put UV light in places we don't want to speak about, if we're still doing those things, I guess.
Is there anything else that I haven't asked that we should add?
No, I think we've covered a good amount of ground there. As I said, I think an important thing is to be critical of everything you see. So obviously we're talking about chloroquine, hydroxychloroquine. There's going to be another one that is going to hit the news in the next few days. I don't know when you'll put this podcast up, but it may have already hit by then. Is the oleandrin, I think it's called. You may have seen it by now. It's the My Pillow guy has been promoting it. And the president has also started to suggest it may be useful. This is another one similar to chloroquine, hydroxychloroquine. It works in the lab. There's no evidence to suggest it works in humans. So sort of just a final message, I guess, is to be critical of these things, is look at more sources than just the one that you get. See if there's any consensus that can be built, and don't expect that there'll suddenly be this miracle cure. It's more complex than that. It's going to take us time, and the best we can do until we have any kind of treatment or a vaccine is to wear masks and to improve the testing and to adhere to social distancing and those kind of things. That's the best way to get this under control and to return to normal.
Well, I thank you for your time, Dr. Stuart Weston from the University of Maryland School of Medicine. Thanks for joining me. This has been John's Post-Life Crisis. Thanks for listening. Go Big Red, and y'all take care and be happy, because it is just a choice you make.